Okay, so let's start. There were around couple of questions right last time, and so we can start with that. So first question was, as we discussed that to avoid multiple in case of bump traffic, right, there is possibility that multiple device might end up sending this broadcast or traffic like app request to the end host, right, if this is connected to multiple devices, right. And for that we discussed that designated forwarder will be used, right. So designated forwarder, out of this one will become designated forwarder, and the responsibility to forward this bump traffic, that is of designated forwarder. So other will not forward that bump traffic, app request or any other traffic. Only designated forwarder will send the traffic towards the host, right, to avoid this duplication. Now selection of designated forwarder, right. So basically it is per Ethernet segment and VLAN. So basically, if you have Mac WAF, right, Mac WAF, let's say you are using VLAN base, right, VLAN base. So for each VLAN, say VLAN 10, you will have RD and RT, right? And then again VLAN 20, you will have RD and RT, right? So in VLAN base, your Ethernet designated forwarder will be per Ethernet segment, right? So this is one Ethernet segment. Let's say this is trunk link and there are, let me clear and then we can just, so maybe let's consider this is a switch, L2 switch, right? And behind that, there are multiple hosts connected, okay, of different VLAN. So your designated forwarder will be selected, right? In this case, if we are using VLAN base, for one is per Ethernet segment. So obviously this is one Ethernet segment, but it is different for each VLAN. So for VLAN 10, maybe for VLAN 10, this guy is the designated forwarder, but for VLAN 20, this guy can be designated forwarder, right? In VLAN base. So VLAN 20. Okay. So basically designated forwarder will be obviously per Ethernet segment, right? Let's say there is one another host connected, right? Another host connected. Then for this, there will be different designated forwarder, right? For this particular Ethernet segment and VLAN, right? So it's a combination of Ethernet segment and VLAN. So if you have one common Ethernet segment and there are multiple VLANs, which are VLAN based, configuration is VLAN based, then you will have for each VLAN, you will have different designated forward. Okay. In case of VLAN aware, it will have only one designated forwarder for all that VLANs, which is part of that VLAN aware bundle, right? So in VLAN aware, we will have multiple VLANs, VLAN 10, 20, 30, right? Let's say in one Mac WAF, right? So all for all these three, it will be one designated forwarder again, but for that Ethernet segment, right? For another Ethernet segment, it can be any other designated forwarder. Is it clear? Any question on this? Okay. So I assume that it's clear, but yeah, let me know if it is otherwise. Okay, now there was one more question, right? And if you guys remember, that is for type 5. So if you remember, we observe that gateway IP address, right, for type 5 was 0000. Is it right? So this gateway IP address in PCAP, right? In PCAP, when we check, right, we observe that it was 0000. Let me pull up that if I can. Not sure if that was this.
I think the IP was 555 in that group.
Okay.
I think.
Uh, yeah, I'm just trying to find that,
Okay.
capture PCAP, which we, open on that day.
Yeah, that's what in that source and destination IP was. I think
Oh,
one
okay,
of them
okay.
was 55.
Is it this one, I think, right?
Uh, let's see.
Hopefully it is this one. Yes, we got it. Yes, IP prefix route,
Yeah,
right? Type 5 route.
55.
So if we see here, right, for each one of this, the default gateway is 0000, right? Correct. So this gateway address was 000. So basically, you can refer this document. So actually, this is the Bible for EVPN, right? In fact, when I started to learn, right, EVPN, I started with this document. Okay, so this is quite big. It's, you can say it is a Bible, and many of the slides are, I have taken it from this document. So basically, in this document, it is for each type, right, or each and every concept. They have, explained in quite detail. Okay, so type 5 gateway IP address, right? There are different ways to implement that, right? Type 5 route, basically. So one is interface full IPv4, right? I am not going to go, I am not going to, we are not going to go into that much detail of this. I just want to point out that, there are different ways, right? Uh, we can configure this IPv4 type 5 routes. Okay. So this is one interface full. And in that interface full, we are sending gateway IP address, which is nothing but the server one IP address. Okay. So when we send out type 5 route for this particular subnet, 10.10.10.0/24, right? We send out, gateway IP address as IP1. And what is that IP1? That is nothing but this server one IP address. So next hop is server one. Okay. So that's how we send out this, but we don't support, Arista does not implement this, right? So there are two other ways, right? Even this is also not supported. The other one, interface full IPv4 unnumbered, that is second way. And this is the third one, interface less, right? Which Arista support. So in this type 5 route, we don't send out gateway IP address is 0, but instead of that, we send out MAC of this particular MAC address of the router, right? So when this guy has to reach to this, send packet to this VTAP, right? It should know the MAC address of PE1, and that's what we are going to send. Okay, we'll discuss during symmetric IRB, right? Why we need that, and how we are going to send this. But just to uh, make confirm that we don't use, basically we don't send gateway IP address, it will be always 0 in our Arista implementation, right? Because we don't support that particular types. We just support interface less model, right? For type 5 routes, and in which we don't have to send gateway IP address, we just have to send the router MAC address. Okay, so that is this router MAC extended community. So we will just send that. Okay, but yeah, if you are interested, feel free to go through this document. Okay, it is quite big, but you guys can go through. And if you have any doubts, please reach out to me. I will be happy to, discuss with you. But it's quite a very good document if you want to thoroughly go through it. And also it has, different scenarios, configuration examples, and everything, right? So it's quite good document, means an extensive. Okay. We already have this document in, I'll share the link. I think we already have this in our EVPN page as well. Yes, this one, right? So first one, under learning basic, this is the first one. Okay, so feel free to go through if you are interested, if you want to deep dive. Okay. Okay, so any question? Okay, so in case there is no question, let's move on to this asymmetric. Okay, any question on asymmetric IRB, what we discussed last time, before we move to the next part of it, that is lab. Any question on this, any of this asymmetric IRB? Is it clear?
Yes, Vishwa.
Okay, perfect. So let's go over the lab topology. Let's first understand how it is implemented, right? What is the configuration for asymmetric IRB, and what are the BGP or routing protocol used, or peerings, right? What different types of peering we have. Okay, so let's understand this. So this is our lab topology, right? Again, we are using COS asymmetric IRB mod. So we have many labs, right? So if you go inside this, we have different labs, AVD asymmetric IRB. This is what we will use in this lab. Otherwise, we also have other labs, right? Symmetric, centralized gateway, multi-home. So there are different labs. For this, we will be using this asymmetric lab, and that's what I have already spin up. Okay. So in this lab topology, this is the basically this is the topology, right? We have leaf pair, leaf 1A, 1B, okay, and another leaf pair, leaf 2A, 2B, VTAP pair. So this is one VTAP pair, another VTAP pair. Host H1 is connected into VLAN 110. Okay, H1 is connected to into VLAN 110. H2 is part of VLAN 111. Okay. Similarly, H3, this 10 is 110, and subnet 11 is 111, H4. Okay. So two VLANs, VLAN 110 and 111, H1 and H3 in 110, and other two are 111. We have SVI configured for both the VLANs on all the VTAPs, right? So all VTAPs are routing VTAP, and we have SVI configured on all the VTAPs because this is asymmetric, right? Asymmetric, you need to have SVI configured on all the VTAPs, right? And virtual MAC is this. This is the virtual MAC we are using for any cast gateway, right? So this is the virtual MAC. Any question till now? Please feel free to ask, right? Because this is very important part of, so feel free to ask if you have any question. Okay. Now we have two spines, right? Purpose of spine is obviously in leaf spine. It's a leaf spine architecture, right? These are all L3 links, right? That's why this is also called L3 EVPN. Okay. So this is called L3 EVPN design, right? Where you're between leaf and spine, you have L3 links, right? L3 connection. So this ET1, this is L3 IP address. One side it will be 255.1, and other side it will be 255.0, right? Is /31. So end-to-end L3 link, right? If this is L2, right? If this is L2 VLAN, then it is called L2 EVPN. Right now we will discuss, and majority it is L3 EVPN only, right? In most of the cases, implementation is L3 EVPN, where between leaf and spine it's a L3. Okay, L3 link, L3 interface. So spine, purpose of spine is for route server, right? As we discussed before, route server or route reflector in case of IBGP, right? We'll discuss that again. But we have basically leaf and spine architecture, right? Now, these are the IP addresses, is orange, right? This orange is VTAP IP address, right? So if you see here, 192.168.254.3, that is same for both this VTAP because it is a MLAC pair, right? So VTAP IP address is same for AMLAC pair, leaf 1A, 1B. And similarly for this 2 VTAP, it is same 254.5, right? 254.5 for this VTAP pair. So this is your VTAP IP addresses, right? End-to-end VTAP connectivity. You can consider it as loopback 1 for VXLAN. Another, if you see in yellow, right, that is another loopback IP addresses, that is to establish EVPN neighborship. Okay, we are using this loopbacks to establish EVPN neighborship. So that are different on each of the devices. Starting with spine, it's all loopback 0 used. Okay, so spine 1 2551 2552. Just make sure, see, this is 254 network for VTAP, and this for loopback another 255 network. Okay, so 254 and 255 network, 255.1, 2, 3, 4, 5 and 6. Okay, so this is loopback addresses, right? We are using, correct, for EVPN neighborship, to establish EVPN neighborship. Okay, any question?
Hey, Vishal.
Yeah,
For like I understand the like how you have loopback 0 for the EVPN neighborship, and then loopback 1 is like where the
VTAP.
VXLAN packets
Yeah,
are
yeah,
sourced from.
correct.
I think I've seen, I'm not sure actually, but I think I've seen like some customers just use loopback 0 and they don't have loopback 1. Is that
uh,
correct?
Loopback 0 is for EVPN. You mean to say they use only EVPN IP addresses, loopbacks?
They use like loopback 0 to form the EVPN neighborship, and then they also do under like the VXLAN interface, they do source interface loopback 0 instead of loopback 1.
Ah, okay, okay. uh, they might use that, but I think that most of the cases what I have seen, it's a different. Generally, they use different, right? So that not to get confused with this, right? So
Yes.
it's better to if they use different. Obviously, they can interchange. You know, you for VTAP IP, they might use loopback 0 and EVPN loopback 1. That can be interchanged, but otherwise it should be different. Okay.
But I think that might be in case of non-MLAG scenarios.
Yeah.
If
So
the
Yeah,
loopback
maybe.
0,
right.
because on the spine one, then there would be two neighborships
Correct. Yes.
with the same IP.
Yeah. So if if you, let's say you don't have this, right? Let's say you have only one loop back for both purpose, as Akshit mentioned, right? What will happen is spine will have same neighbors, right? With for both leaf 1 and 1B EVPN.
Mhm.
Correct. So that will not, basically that will create problem, and that basically where packet should go, right? Because you have two, right? So your neighborship with other folk might not come up if packet is moving this side, right? So
Yeah,
that's the
yeah.
reason you need to have two different loopbacks. Yeah, in multi-home, right? Multi-home, as again Akshit mentioned, you can have different, because VTAP IP address also will be different for each VTAP. There is no AMLAG, so this will be VTAP, let's say 3 IP address, then this will be 4, right? Different, because now you need to have different VTAP IP address for multi-home.
Okay, okay.
Okay. Okay. Thanks Akshit for bringing that up. Any other question? Okay. So now let's understand what are the different routing protocols, or routing protocols we have to use, right? Or route we have to use, right? Can anyone tell me what different obviously one is EVPN, right? EVPN between VTAPs, but before that, what are the routing protocols we need to run here
For
in this topology?
underlay, we can use USPF ISIS.
Okay. So first is underlay, right?
Yeah.
Underlay is what? For what? What is the underlay? What we means, what is underlay?
It is to have uh, connectivity towards the VTEPs.
Yes. So when you H1 sends the packet, right, and you have to encapsulate the packet VXLAN encapsulate, what you do is you use source VTAP IP address as this IP address, and destination VTAP IP is as another VTAP IP address, right? Now, to send packet to this guy, you need to learn the route for this VTAP, other VTAP IP address, right? So in your routing table, you should have 254.4 route, right? That's /32. This route you should have learned, right? And this is called underlay routing, right? So underlay is nothing but, even in VXLAN also we are using underlay, right? If you remember, generally we use BGP. So generally what we do, we use BGP, right, for underlay configuration. But you can use any routing protocol. Either it can be ISIS, right? ISIS, or OSPF, right? OSPF, or even any variant of BGP, that is IBGP or EBGP. Okay. So you can use anything, EBGP, or even if your network is very small, you can use static route also. There is no problem, right? Obviously, that is nobody will use, but that also basically you just need to learn the route, end-to-end routes, right? From basically VTAP to VTAP routes. Another thing what underlay we need is for, so basically you can use any protocol. That is one thing. As we mentioned, right, that we will have this loopbacks to loopback. Basically, EVPN neighborship will be between loopback to loopback, right? This EVPN. And to form EVPN neighborship, we also have to learn these routes, right? We have to learn route, how to reach on this leaf 1A. We need to know, hey, how to reach this particular IP address, right? Loopback IP address. Then only EVPN neighborship between loopback to loopback will come up, right? So that's where we need route for 255.1, right? .1, .2, and then again .5 and 6, right? Other VTAPs, loopback 0. So yeah, routing protocol first is for underlay. What are the purpose? So obviously one is for VTAP reachability, right? And another is for loop EVPN neighborship. To bring EVPN neighborship up, we need to learn loopback 0 routes, right? So this is underlay. You can use any of the routing protocol. Okay. Any question on this? And this underlay, for if we consider BGP, underlay will be between this two interface IP address. Okay. So BGP will be 172.31.255.1 is, let's say, this side, and 255.0 is here, right? So EBGP or IBGP will be between these two IP addresses. Neighbor will be this guy. Okay, not loopback. Okay. And what you will do is you will redistribute connected under BGP so that all your loopback IP addresses will be advertised. You can also use network A statement, okay, to advertise this local route, connected routes. Okay. Any question? Okay.
That's
So
okay for me.
sorry. Yeah, come in.
I was just gonna say it's okay for me. Yeah.
Okay, perfect. Okay, let me just close this one, and then I'll show the configuration in lab. Okay, so this is my leaf 1A, right? Let me clear. So leaf 1A, okay. This one, leaf 1A, show run sec BGP, okay. Now what we are talking about is underlay neighborship, right? So basically what we do in this EVPN, we configure, peer group, so that all all the common configuration we can put under that peer group, right? So for underlay, we have this peer group, underlay peer, right? Name of this peer group. Remote AS is 65101. This is the AS number of the spine, right? 65101, right? So it is 65101. This is the AS number, okay, of spine. And our AS number is 65101. So our AS, okay, both are same. 65101, 101. Okay. So both are same. So basically we are using IBGP here. 65101, 101. Okay. So underlay is 65101, right? Next hop self. Okay. Route map. So basically this is route map we will put. So to filter the traffic, right? Unnecessary traffic, unnecessary routes, sorry, not traffic, routes. Filter the routes. Password, that is just password protected, and send community. And maximum route. So if routes anyway increase, number of routes you receive increases to 12,000, then it might, log error message, or it might shut down the BGP neighborship. Okay. And log message will be there. So this is common configuration for underlay. And if you see the, BGP neighborship underlay, so that is one is 10.255.251.1, right? And 255.0. So these are the two neighbors, correct? For not to this. So this is one, and
Vishal,
yeah, this
that
one.
is MLAG IBGP pairing, right? 251.1.
Yeah, it should be
1L.
Oh yeah, sorry, yeah. Correct. This one.
Yeah.
IPv4 I underlay peers. Yes, this one. Thanks. Yeah, so this is the one where we mentioned peer group and yeah, send community. Oh, that's why I was, that why remote AS is same. Okay, got it. So this 65101 is local AS, and the spine AS is IPv4 underlay peers, right? This one, right?
001, yes.
Yes. So this is one peer, spine one, which is 65001. And the other one is IPv4 underlay peer, this one, right? So, okay. So this two. 255.0, 255.2. So this is 255.1 this side, 255. .1 here, 255.0 here, right? This is 3 and this is 2, 255.2. So we have neighborship, and this 65101 is this guy, 101, and this spine is 65001, I believe, right? AS number. So we have EBGP, right? EBGP between these two. Okay. And yeah, configuration is pretty simple. It's just password protected, maximum number 12,000, and remote AS, right? In fact, this remote AS also we could have put here in peer group, because both spine is same, right? But yeah, so, and then one more is this redistribute connected route, right? And why we have put route map? So that we don't want to redistribute all the connected routes. We just want to keep it, only we want to advertise loopbacks 0 and 1. We don't want to, redistribute any other routes, right? VLAN 100, 200. If you see here, there are many routes, right? We don't want to redistribute all the routes. Show IP interface brief. Right? We don't want to advertise all this connected routes, right? We just want to advertise loopback 0 and 1. So show route map. What was that? Show IP prefix list. So if you see here, right, we have just allowing this to prefix list to advertise, right? This is nothing but our loopback 0 and loopback 1 subnet, right? So we just want to advertise loopback 0 and loopback 1 subnet, right? Not other any routes. So all other routes we don't want to advertise. Okay, that's why this route redistribute connected and route map is there. Okay, any question? Any
These are
question?
/32, right? Where
Yeah, means it is equal to 32. So it we
no,
are
no.
just yeah,
So
this are /32.
yeah, but we are just redistributing entire subnet.
Yes, yes. So if we check, right, show IP BGP summary. So we have this BGP neighborship between two spines, right? Between two spines, right? And show IP BGP neighbor. Let's check one neighborship, right? The routes we are advertising. So we are advertising routes of loopbacks, right?
Okay.
Okay. Any question?
Why is it not advertising the entire subnet?
Which one?
We redistributed the entire subnet, right?
255.3 and 255 and 25 this
0/24 in the prefix list.
come again.
So in the prefix list, we are advertising the subnet, right?
No, it's basically in this subnet equal to 32/32
Okay.
any route, because otherwise see the reason we have configured this is you can apply this on all the devices same, right? But if otherwise what you have to do is you have to configure specifically this, right? That allow this and this, and on other device you have to give 4, right? Or 3, right? Specifically.
Okay.
But because of this config, you can just put this on all the VTAPs, right?
Okay. Yeah, just trying to understand the syntax basically.
Yeah.
So if can we just do like 255.0/32 as well in the prefix list, or does it have to
Here,
be you? Yeah.
no, that will see if you do 192.168.255.0/32, that means it will allow only /0.0/32, right? You want
Yeah, but basically .1 as well.
okay, so you want to put permit
So,
192.168.255.0
.3 like on leaf 1A, right? .3
okay,
/32.
you yes, only this specific you can do.
Okay.
Only this two, right? Without this equal and that you can definitely do.
Okay.
But the point is, this is leaf 1, right? But for leaf 2, leaf 1B, you need to change this, right?
Yes.
And for 2A and 2B, you have to change this, correct? Means basically this permit statement you have to change for each particular VTAP, right? You have to allow that specifically. And there are chances you misconfigure, you miss or change, don't forget to change, right? So if you apply this on all the leaf, that solves your purpose.
Okay, got it.
Got it?
Yeah.
If you apply same, that solves your purpose, because see what here it is saying that from this subnet, you advertise any route which is /32 belongs to this subnet.
Okay.
So that means this 255.3 that belongs to this subnet and it should be /32, then only I will advertise. So basically this will be advertised, and same for 254.3, right? See, one more thing I will discuss. It's not only advertising 254.3 and 255.3. If you see, it is also advertising some other routes, right?
Yes.
We will see that in a minute. But have you got, have you understand the configuration? Any question on this? As far as underlay BGP is concerned?
I'm good.
Okay. Okay. Okay, so yeah, this is eBGP. Now Now, so first is, first was underlay routing, right? Underlay routing. Sorry, anyone has any question? Okay. So this is one is underlay routing. Second is IBGP peering, right? So basically MLAC peer routing between two MLAC peer. So this and this, right? So that is, we can, in this case, we have used IBGP, and generally we prefer IBGP, but again, here also you can use OSPF or any other routing protocol, right? Between these two peer. But again, if you use OSPF here and here BGP, just make sure, you have, means it, there are chances that it might create routing loop, because if you advertise OSPF to BGP routes and BGP to OSPF, right, you have to use filters. Otherwise it might create routing loops, which we have seen in many cases. But okay, so you can use anything, but mostly generally we use IBGP. Why IBGP? Because this both this leaf will have same AS number, right? Same AS number. So that's why we use IBGP. Now, anyone can tell me what is the why we need this IBGP peering between MLAC peer? Basically, why we need to exchange routes between MLAC peer, right? MLAC peer routing.
Like a backup route in case the uplinks go down on leaf 1A or leaf 1B. Not both at once, but on the one. So if they go down on leaf 1A, the two uplinks, then it'll use its IBGP routes leaf 1A pointing to leaf 1B to route the traffic through leaf 1B.
Yes, right. So let's consider this, right? Say leaf 1A, both your uplinks are down, right? Now this H1 is sending traffic which has to go to this H4, right? So what you will do is it will land on leaf 1A, right? You have to encapsulate the packet. Destination VTAP IP is this guy, right? This VTAP IP, but you don't have route, because this route you used to receive through uplink EBGP peering, right? But now that route is not there, right? You don't have that route. So what you will do, you will drop the packet. But obviously this guy is still receiving this route for this 254.5 from its uplink, right? So it has already routes. So if you have routing between these two enabled, right, IBGP or any other, what you can do is this guy also will advertise you this 254.5, right, route. So basically 254.5, right, another VTAP IP route for this guy, another VTAP, you are receiving through two paths, right? One is EBGP, right? That is from uplink, EBGP. Again, in EBGP also, you will receive from both the spines. So spine 1 and 2, right? And you will also receive the same route through IBGP peering from your MLAC peer, that is leaf 1B in this case, right? 1B, you will receive this. So basically, in case your uplinks are down, you still have route in your routing table, which points to that, hey, if you want to send traffic to this guy, VTAP, send it to me. So you will forward the traffic, right, as Kamil mentioned, to leaf 1B, and leaf 1B already know, right, that how to read this guy, and it will advertise towards encapsulate. Basically it will advertise that to spine and then the other guys, right? So basically this will be as a backup. It will provide you backup routes, right, if you have IBGP peering between MLAC pairs. Any question? Is it clear? Okay. And this is the case for, even you forget about EVPN, right? Even normal VXLAN also, this is the case. So first underlay what we discussed, and this IBGP peering, that is also there for normal VXLAN, right? So this both will be there for normal VXLAN as well. Let's go through the configuration. So now this is the configuration, I was before, we were discussing. So this is the configuration for peer, MLAC peer, right? So this one was underlay was for spine, and this is for your MLAC peer, right? Remote AS is same 65101, right? It is same. Next hop self, you will configure next hop self so that your next hop is your own IP address, right? Route map, again, it's a route map to just make sure you advertise, you restrict the route of receive route, installing route only specific to specific one. Otherwise, it might create routing loops. Okay. And then send community and route. Let's check what is the route map, right? Show route. Make routes learned over MLAC peering less preferred on spines to ensure optimal routing, right? So meet 10 match clause, set origin incomplete. Set origin incomplete, right? So basically what we want to do is, basically the purpose of this route map is, so as we discuss here, right? See this particular route, you will receive from two sources, right? 254.5, you are going to receive from two sources. One is through EBGP, which is directly through spine, right? And another through IBGP through 1B, MLAC peer. Okay. Now tell me, if you have to send H1S to send traffic encapsulated packet to this VTAP, which path would you prefer? Considering you have all the paths available, right? Through EBGP, spine 1, spine 2, and through peer, which path you want to prefer?
Through
I'm
the
sorry.
spines?
Sorry?
Through the spines.
Through the spines, right? Yes. So you always want to prefer this, right? Instead of going through this, right? Instead of adding one more extra hope, right? You always want to prefer this. So that's why you want to prefer this EBGP, and that's why you have put route map. When you receive route from this guy peer, you put route map to not prefer this. Okay, not to prefer this routes, but you want to prefer EBGP routes. Okay.
But shouldn't that be done anyway because of the AD?
Yes.
EBGP.
So you are right. In fact, if you have noticed the configuration, right, we have done this, see, distance BGP AD, right? So this is EBGP, this is IBGP, right? So anyway, we have reduced the AD distance of 20, right? So to make sure that we always prefer EBGP over IBGP. So let's check that, right? So 254.5, right? Show IP route. What was that? IP 10 192.168 192.168 254.5, correct? Okay, 254.5. So if you see here, 254.5 we have installed on this leaf device, and which is pointing to towards spine, right? BGP, EBGP route, and AD is 20, right? So basically we have installed route with 20 AD, that is EBGP route. Now let's check what are the other route, right? Show IP BGP IP route BGP, right? Route BGP. Okay. So if we check the same 254.4, right, we are receiving from this two guy 54.5, right? Show IP BGP. So IP route BGP. Okay, let's check this. Show BGP neighbor, right? Let's check this neighbor of IBGP, right? Received routes. So if you see here 254, what was that? 254.5. 254.5, are we not receiving?
No.
Yeah, 254.5. It's here, right? Correct.
254.5. Yes, that's
So
the
basically we
part.
are receiving it, right? But
Mm.
if you see here, this route will have 200 AD, right? So it will not be installed in our routing table because it will always prefer 20 route this. Okay. So even though we are receiving, but as soon as this in both this link goes down, we will have this path route available, right? Which points to the other side, next hop, the peer link. Okay. And if we check this route, right, the neighbor IP route 255.4, basically neighbor IP 255.4, this route for 255.4, right, 255.4, which we are receiving, and show IP route 192.168.255.4. If you check this, we are installing this route, right, directly through neighbor. So for this loopback IP 255.4, we are installing through neighbor, not through EBGP. If you have checked, we might have received 255.4 through EBGP as well, right? But we install it through IBGP. Can you tell me reason? The peer route for this guy 255.4. Loopback IP address, loopback 0. We have installed, yeah, installed through
First, in the recursive lookup that is directly connected. That's why.
Sorry, it is.
So for reaching dot 4,
so this is the route.
reach
See,
to,
this is the route, okay, which we are getting it from neighbor. And if you want to see BGP, BGP neighbor, right, received right, 254, what was that, 255.4. Okay, we are not getting it because okay, can you tell me why, right? So there are two things. One is obviously we are getting only from this guy, right, that is which we have installed. So basically this route, right, 255.4, 255.4, this will be advertised to spine, right, and it will be also advertised to this leaf 1A, correct? Can
through EBGP the AS would be again,
yeah, so why we are not, even receiving this route, right? Or basically we are not considering it, this route here. Yeah, Akshit.
Yeah, because the AS path.
Yeah, AS path for both of this is same, right? So EBGP loop prevention will prevent to install this route, and you are receiving it through local, peer through IBGP, and you will install that route, right? Yeah.
Yeah.
Okay. Okay. So yeah, this is the configuration for IBGP and the reason, right, why we need IBGP. So this is the configuration for IBGP and IP underlay peer. This is the neighbor. Okay. Any question?
Do we have, sorry, go ahead, Tom.
Go, Chi, you first. Yeah.
I just wanted to check, like, do we have to mention somewhere, like when we are using EVPN as the control plane, like the encapsulation should be VXLAN?
Okay. No, we don't have to mention anywhere. The reason is, okay, because as soon as you have configured this VXLAN configuration, right? It will understand that it is a basically data plane is VXLAN, not MPLS.
Okay.
Yeah. Yeah. Any other, Kamil, do you have any question?
Yeah, I do. I guess just to add to your answer to Akshay, I guess for the underlay peers, they're part of the active for the IPv4 address family. And then the just one down here. And then for the EVPN peerings, we enable for the EVPN address family, which is going to use like it knows to use VXLAN. those learned routes.
Yeah, that's right. So basically, okay, so we discuss about these two underlays, right? So one is this underlay right towards spine, and another is MLEC peer underlay. Now this we want to advertise only IPv4 prefixes, right? There is nothing we need to do related to EVPN. So that's why in this config, if you see, if you have noticed this configuration, right? No BGP default IPv4 unicast, right? So basically, generally, when you have configured on for VXLAN, right, router BGP, you don't see this particular stuff, right? Because so generally it uses normal BGP IPv4 configuration, right? That means whatever neighborship you are configured, it will consider it as IPv4 normal BGP, okay, by default. But in this case, because we want to configure IPv4 neighborship for this underlay, right? And also EVPN neighborship, right? EVPN neighborship, we will change the default. We don't want to keep only IPv4 unicast as the default. So that's why we will make it no, right? Now what we have to do is we have to go into that address family, address family IPv4, and we have to activate that. So basically what I'm saying here is this to neighborship, right? This to not EVPN, this to neighborship underlay, I want to activate only for normal IPv4 BGP, right? I want to activate only for normal IPv4 BGP, okay, not for EVPN. And that's why this EVPN overlay peer group or neighborship, I have made it no, okay. Similarly, for EVPN neighborship, I just want to activate EVPN neighborship only with this guys, right? EVPN overlay. I don't want to run EVPN for this underlay neighbors, right? So that's why I have not activated it. Okay, I have activated only EVPN overlay. Okay, is it clear?
Yeah.
Okay. So now let's, so yeah, you know, we discussed that why we need underlay, why we need IBGP peering with MLAC peer, right? IBGP or any other OSPF. Third is EVPN neighborship, right? Why we need EVPN neighborship, right? EVPN neighborship. So see, first two is already we use in VXLAN also, right? This is the one which is new. Now, can you tell me why we need EVPN neighborship? And with which, say, between which devices we need EVPN neighborship?
I think we need neighborships between each tunnel endpoint, so each VTEP. So like the purpose of VXLAN is to create layer 2 tunnel, and you're extending the VLAN with the VXLAN encapsulation. So I think you need EVPN neighborships at each end.
Okay, but what is the purpose of EVPN neighborship? It's not VXLAN, right? For that we have VXLAN data plane, right? Why EVPN neighborship?
To
Between
advertise the routes, basically the host routes, like the server route via EVPN, like 10.1,
yes,
10.1.
yeah. So which are type 2 and type 3 routes, right? In case of L2 EVPN, right? We want to advertise type 2. Type 2 is nothing but we want to advertise MAC and ARP information, right? And type 3 is nothing but we want to advertise floodless information, right? Floodless information. And that's why we need EVPN, right? To advertise type 2 and type 3 routes for L2 EVPN. Right now we are discussing L2 EVPN. Asymmetric IRB is all about L2 EVPN, right? So L2 EVPN, we want to advertise MAC and ARP information, whatever MAC learned here, right? For this host and this host, and ARP learned here for both the hosts, we want to advertise that, right? And that we advertise using MPBGP, right? MPBGP protocol, which is nothing but by using EVPN. Okay, so we want to advertise this MAC ARP and floodless. Obviously, we don't want to configure manually floodless. So we want to use it type 3 route to advertise floodless. Now to which devices, right? So obviously all other VTAPs need to learn MAC, ARP and floodless information, right? So basically that's why we need EVPN, that is for control plane, to advertise this information to other VTAPs. So basically we need EVPN neighborship, right? As Kamil mentioned, with other VTAP pairs, right? So this is what our requirement is. EVPN between this to this, right? EVPN between this guy to this guy, and EVPN neighborship between this to this. Okay. Is it clear? Any question?
But if we configure like EVPN between leaf and spine, with an IBGP, this spine should be able to route reflected, right?
Yes. So we'll come to that point. So see,
Okay.
generally the reason, basically what I want to mention is we don't have to configure EVPN neighborship between leaf to spine. No.
Hmm.
Actual purpose is we whatever this information MAC are, we want to give it to other VTAPs, right? Now
Yes.
consider you have in your network 50 VTAP pairs. 50 VTAP pairs. What will happen?
Full
Right?
mesh.
You have EVPN neighborship with all this 50 into 200 VTAPs, right? So on one leaf, you need to have EVPN with 100 peers. Same one B also has. It's like a full mesh, right? Then only you can advertise all your MAC ARP information to all the VTAPs, right? Through EVPN, correct? Which is not scalable, right? So that's the reason what we are doing here is, instead of configuring EVPN neighborship between this leaf devices, right? What we do is we use Spine as a route server, just, forwarder, you can say route forwarder, right? And for IBGP, we also use route reflector, basically concept, right? So we use this Spine as a route forwarder. So what we do is we create EVPN neighborship between leaf to spine, and that is loopback to loopback, right? So basically we configure EVPN neighborship loopback to loopback, and this loopback reachability is already we got it through underlay, right? Underlay route, we know how to read this to this loopback. So we have route and we can bring up EVPN neighborship between loopback to loopback, right? So basically now leaf 1A has only 2 EVPN neighborship with 2 spines. Okay, both the spines. If you have 3 spines, then obviously it will have 3 EVPN neighborship, but not more than that, right? So only 3 EVPN neighborship, right? What you will do is this type 2 route, right? Type 2 and type 3 route, right? 2 and 3, MAC and ARP, right? And floodless. You will advertise that route to this guy, spine, both the spines, right? You will advertise that. And then this spine will just forward that routes to other VTAP pairs. So this guy, and this guy. So eventually, what was your purpose? Basically, this MAC type 2 and type 3 route, you wanted to advertise to other VTAP pairs, right? Which is eventually your purpose is solved, right? Spine is forwarding it to other VTAP pairs. And finally, your route type 2 and type 3 route, which is originated from here, is reaching to these 2 pairs, right? All the VTAPs, other VTAPs. So through Spine, you are using Spine as a route forwarder. You are advertising that route and all the other VTAPs will learn about it, right? So that's the, in for scalable network, we use Spine as a route server or forwarder. Is it clear? Any question on this? Okay. So let me quickly show you the configuration, right? And then we can stop here and then maybe if we can discuss further in next. So this is the configuration for EVPN overlay. So that is called overlay, right? EVPN overlay configuration, overlay. So we have update source loopback 0. Why you need to configure loopback 0? Because you are update source loopback, because your EVPN neighborship is between loopbacks, right? Loopback 0. So that's why you have to configure loopback 0. This BFD, if you want, you can configure. Again, you have to configure multi-hop, right? Because you have neighborship between loopback to loopback, right? Password protected, send community extended, because you want to advertise, EVPN routes, right? MPBGP routes. And maximum route 0. You can configure this 0, or you can have limit, but you need to be aware that if it is not, that sure that it should not increase 12,000, then you can. 0 means it can allow any value, any number of routes, right? There is no limit. 0 means that it's not only 0 route. Okay. So, but yeah, you have to make sure, because in EVPN, if you have 10,000 hosts, right, then you will have 10,000 MAC and 10,000 ARP information, right? So obviously you will easily go beyond this 12,000, and EVPN neighborship might come down, or it might, give some log message warnings, right? So that's why it is configured 0, but you should know, right? It should not that you configure 0 and your resources are not enough, right, in your switch. So just make sure this is not the case. Okay. So this is the EVPN configuration, and this is the EVPN neighborship configuration, right? So this is both the spines, 255.1 and 255.2, 192. So this 192 loopback addresses, right? So you have this EVPN neighborship, and also you have activated EVPN only with this guys, right? Overlay. You don't want EVPN for this underlay peers, right? You want only with overlay peers. So that's why you have activated only that, correct? Show BGP EVPN summary. So it shows you, right, both the spines neighborship only, right? And show IP BGP summary, that has neighborship with spine only, but loopback, not loopback IP address, right? Physical IP address, interface IP address neighborship. And one is IBGP with MLAC peer, right? So you don't want to both at each has spatial purpose. You don't want to combine both, right, with each other. Okay. Any question?
Hey Vishal, I got a couple.
Yeah.
You've covered it. Just if you scroll up to you have like the BGP weights, like distance BGP 20, 200. What was the first one? The first one was EBGP. The second one was IBGP.
Yes. Second is
okay.
IBGP, and third is, I think, 65101 distance BGP, right? Say 20, IBGP is 200, and this is BGP local route admin distance. Yeah, local route.
Well, how come we need this command? It was something to do with the backup IBGP route, I think.
Yeah, so this command is for, we always want to prefer EBGP route compared to IBGP route. So if we receive EBGP route, right, and also IBGP route, we always want to prefer this one rather than this.
Okay, what's usually better, the administrative distance, if it's higher or lower?
Lower is better. So if you see here, connected route is always 1, right? So that will be preferred first, right? Connected is always 1, and then EBGP is 20 and IBGP is 200. So yeah, lowest is the preferable.
Right. So even without that distance BGP command, like when we receive the EVPN route, which is where we prefer to receive the route, right? So we don't go over the peeling, because it's through EVPN is the ideal path.
Yes.
So even without that distance BGP command, we're still going to send over the uplinks, not through the peeling, right? Not through IBGP, but through EVPN.
That's why we want to prefer EBGP routes compared to IBGP, so that our first preference is always going to be spine. uplink rather than sending through this path, right? Through IBGP neighbor. Instead of this way, we always want to send directly, right?
Yes,
So,
yes, but even without the command, we still do that, right?
without the command, we okay. So then we might receive both routes with 200, right? Let's say this VTAP IP.
Okay.
Then it might choose anyone, right? Both has same AS number, right? Both will have same AS number, right? Because AS number is this one AS, second AS, right? IBGP is not going to add any AS number. Same AS number, AD is same. So it might choose EBGP or IBGP route. So that's why we want to specifically choose this guy. We are reducing AD to 20.
Ah, I see. I see.
Yeah. So
Okay.
even you consider you are not using IBGP and you are using OSPF, right? OSPF. So you are receiving route through OSPF, right? You are receiving route from OSPF and EBGP. Still, you want to choose EBGP, that is from spine, because OSPF AD is 110, and you want, if you keep it default, then BGP is 200, right? So what will be default? BGP is 200 EBGP. So it will choose OSPF, this path, right? So that's why we want to keep it EBGP, want to keep it as 20 EBGP, so that it always chooses the uplinks.
I see. Okay, makes sense.
Even
So we're changing the
yes,
administrative distance for EBGP, right?
yes, yes, yes.
Okay, I see. Yeah,
Yeah.
makes sense.
So even
Thanks.
within BGP, you might have other, there are other route BGP route selection, path selection, where you might, if you go AS number, it checks the AS number, and then AD. First is AD, obviously, then AS number and all that, right? And you might see that, you might choose EBGP over IBGP, right? So in this condition, even though you receive from both and same AD, you might end up choosing EBGP, but it is always good to reduce EBGP distance AD to 20, so that even though you use your OSPF, right, you always choose this EBGP, that is uplink. So basically, just to avoid any by mistake or any combination might choose, I end up this path, you better to change it to 20.
Okay.
Right? Because when you have to choose between two routing protocols, BGP and OSPF, only AD will be considered, right? There is nothing else, right?
Yeah.
Okay. Any other question?
Actually, I have one more.
Yeah.
Just it's a quick one, simple one.
Yeah.
For the backup route, we pair with leaf 1B, and it's using that neighbor 10, 255, 225. If you just go back to the configuration, it's a little bit up. Yeah, this one.
Yes.
That's the IP. What IP is the 10? Oh, that's the SPI, right?
Yeah, it is SPI.
That's the M. Okay.
10. Yeah, this, right? This subnet. VLAN 4093. That is, in fact, if you notice here, there are between MLAG pair, there are two SVIs, right? So one is for MLAG and one is for IBGP neighborship. So you have configured two VLANs between MLAG pair communication. One is obviously for MLAG, other is for IBGP neighborship establishment.
Yes. Yeah.
You can use one, but yeah, just to keep it separate, right? Which will be also good for troubleshooting. They have used two different SVIs for both the purpose.
Yeah. Okay. Thanks, Vishal.
Okay. Any other questions?
And this IBGP VLAN, is this passed over peer link or do we need a separate term for this?
This, right? This VLAN?
Yeah.
That is only for peer link.
So peer.
Yeah. So in fact, if you see 251.0, right? If I go to leaf 2A, okay. Oh, caps lock. Okay, it's a different, but otherwise, see, basically my point was that even you can use the same, right? Because you are not advertising this route to any other. It's going to be local between these two guys, right?
Yeah.
Two leaves. So if you can choose to use same IP addresses, okay, so that should not be problem, considering you are not advertising that route subnets. And in this case, that's why, you know, if you remember, we have route map, right, to block that routes. We are advertising only loopbacks, right, not other routes. Redistribute connected, right?
Yep.
Yeah.
Okay, anything else? Any other questions? Fine, I think then in that case, let's